Pozdrav svima! Evo, dobio sam, kao što vidite ovdje, naslov na engleskom jeziku, dobio sam bio molbu od nekih od vas bih li mogao i na engleskome ispredavati ove stvari. I evo, za početak, zašto sam davao bio svoja predavanja na hrvatskom jeziku? Imam sreću da sveukupno imam 3 razreda četvrtoga srednje i da mogu onda unificirati stvari među vama i da vam svako dobije jednako predavanje od mene iz pojedinog dijela gradiva. Sada, zašto je to meni osobno dobra stvar? Moj tjedni promet uploada videa je preko 150 gigabajta na tjednoj razini, s obzirom da ja radim za sve svoje razrede videe s predavanjima. I to ako pomnožite sa 4 i ako malo pogledate koliko to zauzima samo upload mog dijela prometa, da je to jako puno, a meni se to ne plaća. Ja imam neku verziju fleta i imam neke pogodnosti s obzirom na to, ali sam morao neke dodatne stvari dogovoriti da mi se to onako... Ali eto, ne bih vas htio brinuti ili opterećivati sa svojim financijskim stvarima i koliko imam problema sa te strane, jer hvala Bogu da to niko neće platiti, nego ću si ja sam iz svog džepa morati to riješiti za vas. Jer eto, uvijek se može ići na taj način. Ali dobro, neću vas opterećivati sa time, ali rekao ovako. Pošto sam dobio nekoliko molbi od vas da napravim i na engleskome, odlučio sam, evo, na primjer, današnje predavanje ću vam dati na engleskom, pogotovo zato što se nekako nadovezuje na predavanje od profesora Vua koje sam vam bio dao prošli tjedan. Ali eto, vi ste do sada svaki put dobili što se tiče vokabulara ili prezentacije sa time, pa onda potpora vam je na predavanje na hrvatskom jeziku za to da možete onda si usporediti i tako, zapisati ono što hoćete za engleski jezik. I videe tipa od profesora Vua, pa da možete onda vidjeti kako se koristi i koja notacija se može javiti u nekim drugim zemljama ili koje su preferencije pojedinog profesora. Tako da eto, profesor Wu koristi dy kroz dx, mi koristimo f derivirano x zapis. I o tome neću sad ići detaljno za koji, to sam dao bio video, odnosno da sam dao bio i link na Wikipediji gdje je dosta lijepo objašnjeno razlike između kojega, ali da u biti su sve derivacije, odnosno derivatives. Sad, today's lesson is higher derivatives. Basically, I'm going to go through a couple of examples of functions and how to find their higher derivatives from the second derivative, third derivative, and so on. For Croatian language, higher derivatives are derivacije višeg reda se govore, znači red ne stupnja, pa da možemo onda usporediti sa time. Okay, so let's go with the first example of a higher derivative, where we are going to find higher derivatives for the function where f of x equals to, just a second, 5x to the power of 3 plus 2x squared minus 3x and minus 6. So this is the given function. Basically, this is polynomial. This is polynomial of third degree, because we have x to the power, we are given x to the power of 3 in all of this. So, to find the derivative, we have to differentiate the function f. So, basically, there are two ways of differentiating. You can either go with the limit definition, where you have to find the limit where difference of x's goes towards 0, or we can apply the rules, we can apply the forms to find the known forms, the rules to find the derivative itself. So derivative, just so that we go through it once again, derivative is the result of differentiating a function. So, the rule itself here that I'm going to apply is going to be apply the rule of indices. So, x to the power of 3, I have to find its derivative, x squared, x and 6. 6, when you differentiate the 6, you're going to get 0. basically. So it's a simple one, while everything else is going to be 5 times 3x squared plus 2 times 2x minus 3. Simple enough, should be. Now we have to calculate everything. So it's going to be 15x squared plus 4x and minus 3. And this is the derivative of function f. This is also called the first derivative because it's the first one that we've done. But as Professor Wu said, we can continue on. We can continue to find the second derivative, third derivative, and so on. Why? Because the derivative itself is a function. Specifically in this here example, it is square function. So let's continue on. Now you can write it in two ways. I'm going to now write it with another dash, adding the dashes, so to say. It's also in the video told like that. So the second derivative is going to be, now we have to find derivative for each of these. So it's going to be 15 times 2x plus 4. Or second derivative of function f is going to be 30x plus 4. So this is the second derivative. Let's continue on. Let's find the third derivative. It's going to be with 3 dashes. So basically what's going on here, to find each next derivative, you have to find the derivative before that. So for us to be able to find the third derivative of a function, we have to find both the second and the first derivative before that. So third derivative of 30x plus 4, or derivative of 30x plus 4, is going to be just 30. Let's continue on with the fourth derivative. Now, there are a couple of ways we can write it down. Either add another dash, so 4 dashes, or, well, there is 4 of them, and in the video it's also written down each of them as this. So second, third derivative, here would be the fourth derivative. I'm going to not write it down like here. I'm going to write it here as fourth derivative. It's not written as a fourth with the letters, but just like this. And there is another way you can write it down this here way. Is, well, we just added the dashes. Which symbols does this represent? 1 dash is 1, 2 dashes are 2, 3 dashes are 3, 4 dashes are 4. But instead of 4 dashes, we used to write it as IV, or Roman numbers. So there is also Roman numerals that we can use to write down the derivative, or which derivative it is. Now, why in this here form, the normal form, is the 4 in the bracket? Well, if you write it down as 4 like this, this basically means f to the power of 4 of x. This is index form. This is derivative form, okay? So this is not the same thing. So watch out for that. You can also write yourself down that this is the index form, and you don't write it loud like that. The basic example for this, and this is also in the video, said that sinus square of x is basically sine of x squared. So watch out for that, okay? While if it was written as sine 4 of x, like here, this would be we would have to find the fourth derivative of sine function, okay? Now this is the idea behind all of this. Okay, so you can also go ahead and find the fifth derivative, sixth derivative, or nth derivative. Nth derivative is usually written down as f, the n derivative of x. And for us, in order to be able to find the nth derivative, we have to find the one before it and then differentiate it. basically find f n to the power, not to the power of my n minus 1, but n minus 1th derivative, and then and this is the form you can write down. It's also in your textbook, but it's not something that you actually have to use or know as it is. But the idea is basically this. For us to find any derivative, 5th, 6th, 10th, 100th, you have to find all before that. So, for example, for the 4th derivative here, we had to go through the 1st, 2nd, and the 3rd derivative. One more thing about this, let's finish this task. We didn't write down what is actually the 4th derivative of function f. Well, 30, when you apply the constant function, well, its derivative, it's 0. And any other after that is again 0. Now, this is the example of polynomial. For example, if you were given a polynomial of degree 10, you would be able to find first 10 derivatives without any issues. Going down each step, the second derivative, third derivative would be 1 degree lesser than the original one. And after the 10th derivative, because for example the third was still a constant, the 10th derivative of the polynomial that's a degree 10 would be a constant, and after that all of them would be 0. 0 is also a constant, but after that, for example, 20th derivative would be again 0, and so on and so on. So this is with polynomials. Now let's look at the another example of a function that is not going to be given as polynomial, but as trigonometric function. So example 2 is going to be f of x equals to sine x. We can also write it down like this. So f of x is sine of x. First derivative is simple enough. Cosine of x. There you go. Now basically, each time, and I'm going to write this in the future, we differentiate the one before it. So for the second derivative, I have to find derivative of cosine of x. And that is minus sine of x in this case. Let's continue on. Third derivative, I have to find derivative of sine x, of minus sine x, which is minus cosine of x. Let's find the fourth derivative. I used Roman numerals. You're gonna see I combine. Sometimes use Roman. Then sometimes I use normal. So in this case, minus cosine of x, find its derivative. It's minus sine of x, which is sine of x. We can continue on. Let's find the fifth derivative. So for the fifth derivative, I'm using sine of x, and this is cosine of x. Now this is the example of a function which doesn't matter how many times you differentiate it, second derivative, fourth derivative, 10th derivative, each time you're going to get a new function, or it won't be new, they're going to repeat itself periodically. And this is one more thing about periodic functions. Sine function is periodic. Similar thing is to the cosine function. It's also periodic, that derivatives of periodic functions are probably again going to be periodic, or appear periodically. So there is more to it than just the simple derivatives or finding the derivative. Now this is again the example. Why I wanted to show you this is because in this here case, for finding any other derivative, fourth, fifth, sixth, you have to find all those that are before it. you cannot skip ahead. Now, if you see that things appear periodically, in this, like in second example, well, here you can then say, aha, I have, for example, these 4 derivatives, and then I can find the 100th derivative immediately applying some specific periodic law or something that you noticed, so to simplify things. But that's up to you. Now, the one last task that I want to show you in all of this is the task from your textbook. I believe the page is 25, and it's going to be task 28. 28.1, where f of x equals x minus 1 over x plus 1. Now, what you should see here is that we have a quotient or division between two functions, x minus 1 and x plus 1. And there is a certain law or principle that we can use to solve and find the first derivative. So let's find the first derivative. Basically what happens here is that the numerator is going to be squared. Okay? While above we have x minus 1 derivative times x plus 1 minus x minus 1 times x plus 1 derivative. Let's find everything that we have to. One more thing that I have to tell you is x plus 1 squared. Leave it as that. Don't use the square binomial, because there are going to be situations where things might get simpler, where you will be able to cancel things out and simplify. While if you use the square binomial, well, then you cannot cancel things out. So let's just copy x plus 1 squared. While above, x minus 1 derivative is going to be 1, and x plus 1 derivative is going to be 1. 1 times x plus 1 is x plus 1, minus x minus 1 times 1 is going to be minus x minus 1, or minus x plus 1. The last step is that we have 2 over x plus 1 squared. Now, I won't leave it as in this here form. I would rewrite it down, if it's possible, as 2 times x plus 1 to the power of minus 2. Why? Well, you can use this here, but in this here form, we can go through it as in what we did. Sorry, I have some issues with my voice. I apologize for that. Where this here is going to be simpler to solve because we have composite functions. That's why we can use it and rewrite it in this here form. Because basically you have a big function, big or outer function, which is something to the power of minus 2. Something to the power of minus 2, you can then find its derivative, and after that you have left x plus 1 as the second function, inner function. So let's find the second derivative. For the second derivative, basically we have to find x plus 1 to the power of minus 2, its derivative. What this means is constant times something with the x. Constant is left outside, nothing happens to it. While x plus 1 to the power of minus 2 is going to be minus 2 times x plus 1 to the power of minus 3. So this is basically the index rule. And then multiplied, well, with what's inside, and that's x plus 1 derivative. Now, basically what I've done here, I've done the chain rule. Chain rule is something that I encourage you to do when you have composite functions to solve it. Basically, now the only thing left is you have to find the derivative of x plus 1. Well, 2 times minus 2 is minus 4. times x plus 1 to the power of minus 3, you leave it as it is, and times 1. Well, you can write it down or leave it as it is. I'm going to put it into brackets just so you know that we can leave it on the side. You don't have to write it down in the future. Let's continue on, because task 28 asks us to find fourth derivative. So, third derivative is going to be minus 4 times x plus 1 to the power of minus 3, and let's find its derivative. So minus 4 is left, times minus 3 times x plus 1 to the power of minus 4 now. So basically I found the derivative of x plus 1 to the power of minus 3, and now I have to multiply it with x plus 1. What's the inner function? It's all together 12 times x plus 1 to the power of minus 4. X plus 1 again is 1 when you the derivative of x plus 1 is 1, so you can leave it on the side. For homework, I would leave you to find fourth derivative. Find it for yourself. Now the method you can apply to that. And one more task I would ask you to do for your homework, and that is the 28th task, the second subtask, where you have f of x equals 1 over 1 plus x. Now, first thing that I would do here, before I went and find any derivative, is rewrite it down as 1 plus x to the power of minus 1. Why? Because then you have basically the method of the subtask 1 to solve everything. Okay, now one more thing that I would want to talk to you about. Why didn't I do it right at the beginning? You could have done it right at the beginning, but it wouldn't matter, because you have the quotient of two functions. Now, why have I rewritten here, or in this here case, the given results, or the functions, however you want to say it, is because you have constant divided by a function. Constant divided by a function. In that case, this here form, if you ask me, is simpler, because basically from now on you have the composite functions and you have to find derivatives of composite functions. That's it. So these two tasks I would like you to do for homework, to try it for yourself. There are going to be some other on the Lumen. I'm going to talk about them also. I'm going to give you them on the Lumen, but there you go. Okay. Thank you for listening, and see you in the next video.